This is Cardinality Example 2. We are to consider the function f from the natural numbers to the power set of the natural numbers given by the rule f of x equals the intersection of the set containing 1 and 2 and the set containing x. And we are to determine if f is 1-to-1, onto, and or a bijection. To do this, what I'm going to do is create a table. And this is the strategy that I would encourage you to use for problems 1, 2, and 3 in the cardinality assignment. So making a table. In the first column, I put my domain, the natural numbers. In the second column, I put my target, the power set of the natural numbers. Now the natural numbers start at 0, so we have 0, 1, 2, 3, 4, 5, and so on. And now I'm going to fill out the power set of the natural numbers column using my rule, f of x. All right, so f of x is this rule, the intersection of the set containing 1 and 2 with the set containing x. Now, right here, I'm going to put f of 0. Okay, so f of 0 is the set containing 1 and 2 intersected with the set containing 0. To fill this out, now think about what's going on here, right? X is just a placeholder, right? So if I want to figure out f of 0, I replace the x with 0, and that's what I've done below. Okay, now I want to ask myself, what is the intersection of the set containing 1 and 2 and the set containing 0? Remember that the intersection is the set of all elements that are common to both sets. There are no sets, or there are no elements common to both sets, so the intersection is the empty set. The empty set there. Now I'm going to figure out f of 1. What's common to the set containing 1 and 2 and the set containing 1? That's right, it's the element 1. Now figuring out f of 2, we see that 2 is common to both sets. Now figuring out f of 3, we see that nothing is common to both sets. So our answer is the empty set. Similarly, f of 4 is the empty set. Similarly, f of 5 is the empty set. And we see that since all numbers, all natural numbers greater than or equal to 3 are not going to have anything in common with the set containing 1 and 2, f of x for x greater than or equal to 3 will always be the empty set. Now let's determine if our function is 1-to-1. Remember that a function is one-to-one if, when we fill out a function table like I have here, that if all elements of the second column are different. Are all elements of this column different? No. We see right here that we have the empty set and the empty set. Those are the same thing. In fact, there's many entries in this second column that are the same. So this says not one-to-one. Now, because we know it's not one-to-one, we know immediately that it's not a bijection. That f is not a bijection. This is because a bijection is a function that is both one-to-one and onto. If it's not one-to-one, then it's not one-to-one and onto. And now let's determine if f is onto. Well, from the previous example, we know that no function from the natural numbers to the power set of the natural numbers is onto. And here we have a function from the natural numbers to the power set of the natural numbers. So we know immediately, without doing any work, that f is not onto.